For this lesson, we're looking at writing scientific notation properly. One thing we need to always remember about scientific notation is that the decimal point always follows the first non-zero digit. So we should have a decimal point here, and on the second example, we should have a decimal point here. And since these aren't written that way, we need to make a little bit of an adjustment. One way that the book worked these problems out, and I thought was kind of interesting, it's not the way I learned to do it, but I think it's pretty valid, is to take a number like 25 and write it in scientific notation so that we see 2.5 times 10 to the first times 10 to the negative fifth that we originally started out with. And then we're going to deal with this part of the problem just like we would using the rules of exponents, because 10 to the first times 10 to the negative fifth means we're going to look at 10 to the first plus negative 5. And if 1 plus negative 5, that gives us 10 to the negative fourth. We're then going to bring that back over here, and now we have 10.5 times 10 to the negative fourth for our answer on that problem. I thought that was an interesting way of working it. Definitely not the way I learned how to do it, but a very valid way of doing the problem. The same thing applies down here. If I take 25 hundredths and write it as 2.5 times 10 to the, and since we move to the right, we have negative 1 times 10 to the fourth. Again, we apply that laws of exponents here. 10 to the negative first plus 4. Now we have 10 to the third. We've covered this previously. 10 to the third. We bring that back up here. Now we have 2.5 times 10 to the third. So it's definitely a different way than what I learned how to do it as, but I think it's a very valid way and an interesting way that the book goes about solving the problems. We'll talk about this and the other method in class tomorrow, but give this a whirl, see if you can make it work, and see you in class.